Right guys, in this video, we are going to discuss few more questions on three-phase transformers related. Let's see. A three-phase delta star. A three-phase delta star has a secondary to primary turns ratio. Nothing but simply they given K. Secondary to primary turns ratio is 5. For the primary voltage of 400 volts, nothing but they given line voltage of delta 400. The secondary line voltage will be, the secondary voltage would be nothing but line voltage. We need to give the answer in terms of line. So tell me, this is, what will be the phase voltage of delta? In delta, phase voltage, line voltage, both are same. If this is a primary phase voltage, nothing but E1. This is N2 by N1 is equals to E2 by E1. Then what is E2? E2 is equals to 5 times of E1. 5 times of 400. 5 times of 400, which is E2 is equals to 2000 volts, which is a phase voltage of star. If the phase voltage of star 2000, what is phase voltage? What is line voltage of star? Root 3 times of phase voltage. Root 3 times of phase voltage. So root 3 times of phase voltage. Root 3 times of 1000, how much? 1000 into root 3, 1700 something. Then 2000 into root 3, 3400 something. 3464. Simple question. A three-phase star-delta transformer, secondary to primary turns ratio they given, secondary to primary turns ratio is 5. The primary line current 10 amperes, the line current of star 10, ultimately phase current of star also 10 because line current equal to phase current. This is equals to I1 by I2, I1 by I2. I want I2 sir. I2 is equals to I1 by 5, which is equals to 10 by 5, which is equals to 2 amperes. The secondary phase current, the phase current of delta is 2 amperes. Now the secondary line current will be, in delta line current they are asking, which is root 3 times of 2. Root 3 times of 2. So the answer is 3.6, 3.4. Because 1 into root 3, what we know? Now the 2 into root 3. 1.7 doubles, 3.4 something. Simple question. Three-phase transformer bank consists of 3 identical transformers. 15 kVA single-phase transformer. 15 kVA single-phase transformer connected in delta-delta. 15 kVA single-phase transformers are connected in delta-delta. The bank supplying 20 kVA load. 20 kVA load. Here 3 single-phase identical transformers are there, each rating of 15 kVA. Each rating of 15 kVA. 15 kVA, 15 kVA, 15 kVA. But I have very little load, just 20 kVA of load. Actually, I can load up to 45 here, but I don't have that much of load. I have only 20 kVA load. Unity power factor 3-phase load. If one of the single phase transformer develops a fault, now we have only 2 transformers. Removed the load carried by each of 2 transformers. Now the load carried by each of the 2 transformers now operating in open delta will be dash kVA. Now what is the load on this? The load on this is 20 kVA ultimately. The load is 20 kVA. Sir, is it okay, sir? Actually, here the load is 20. So here we need to apply 20 by root 3. No, sir, not 20 by root 3. Actually, here we can 45 kVA. Here we can 45 by root 3. 45 by root 3 we can. But I have just 20 kVA load, which is 20 is less than 45 by root 3. 45 by root 3 nothing but 15 into root 3. 15 into root 3 nothing but 15 into 1.7 is more than 20. But I have a load just of 20 kVA. Only I have a load of 20 kVA. This 20 kVA is less than 45 by root 3. This 20 kVA is less than 15 into root 3. That's why I can apply 20 kVA on the open delta system easily. It will not get so overloaded. I can apply 20 kVA on this. If I apply 20 kVA on this, the load carried by each of two transformer is 10 kVA. Each of two transformer is 10 kVA, 10 kVA, it can share easily because its rating is 15 kVA. Actually, how much we can apply on load on this? We can apply load on each transformer is 15 into root 3 by 2. 15 into root 3 by 2. How much 15 into root 3 by 2? Can you tell me? Once I will check here. 15 into root 3 by 2. How much actually? 15 into root 3 divided by 2. I can around 13 kVA load on this without overloading. What is a load carried by its 86.6%, right? If you calculate 86.6% of 15, it's around 13 kVA. But now how much it is sharing from this? Only 10 kVA is sharing from this. So each of two transformer can share a load of only 10 kVA. What I discussed here, general గా 15 kVA, 15 kVA, 15 kVA ఉంటే మనం 45 kVA లోడ్ వేయొచ్చు. బట్ నా దగ్గర 45 kVA లోడ్ లేదు, ఓన్లీ 20 kVA లోడే ఉంది, వేశాను. ఒక ట్రాన్స్ఫార్మర్ డ్యామేజ్ అయింది. అప్పుడు దీనిపైన ఎంత లోడ్ వేయొచ్చు? నేను 45 బై రూట్ 3 kVA లోడ్ వేయొచ్చు. లేదంటే 15 ఇంటూ రూట్ 3 kVA లోడ్ వేయొచ్చు నేను. బట్ అంత లోడ్ లేదు నా దగ్గర, 20 kVA లోడే ఉంది. ఇది ఎంత వస్తుంది సార్? 20 కంటే చాలా ఎక్కువ వస్తుంది, 25 వస్తుంది అరౌండ్. నా దగ్గర 20 ఉంది కాబట్టి 20 వేశాను. అప్పుడు ఈచ్ ట్రాన్స్ఫార్మర్ ఎంత షేర్ చేసుకుంటుంది? 10 షేర్ చేసుకుంటుంది. మరి ఓవర్లోడ్ అవ్వదా సార్ అంటే, ఇక్కడ ఓవర్లోడ్ అవ్వకుండా మనం ఎంత లోడ్ వేయొచ్చు? 86% వేయొచ్చు. 15లో 86% అంటే అరౌండ్ 13 వస్తుంది. బట్ నేను ఎంత వేస్తున్నా? 10 వేస్తున్నాను కదా, ఏం కాదు, రైట్? 3-phase delta star transformer. Delta star transformer supplied 6000 on delta, 6000 on delta. The terminal voltage on the secondary side, when 0.8 lagging power factor is 415 volts. 415 volts is the voltage at 0.8 lagging. The equivalent resistance drop for the transformer is 1% and 5%. This is percentage resistance, this is percentage reactance. The turns ratio of the transformer is, the turns ratio they are asking. So here the line voltage is 6000. What is the phase voltage? Line voltage, phase voltage both are same. This is also same, 6000. The primary phase voltage is 6000. Okay now. Then here they given V2. We need to calculate E2. First of all, what is the voltage regulation? Voltage regulation is equals to percentage R into cos pi plus percentage X into sin phi. Percentage X into sin phi. How much? 8% plus 30%. So 38% by 10, which is equals to 3.8% is the voltage regulation. 3.8% is a voltage regulation. That is E2 minus V, which is a load voltage, load terminal voltage they given, V by E2. Let's calculate E2, that's it. Then you will get turns ratio, transformation ratio, everything we can get. So tell me what is the value of E2 from this? 3.8 into E2 is equals to 100 into E2 minus 415 into 100. Bring this 415 into 100 here. 415 into 100 is equals to 100 minus 3.8. 100 minus 3.8, 96.2 times of E2. 96.2 times of E2. So simply what is E2? E2 is equals to 415 into 100 by 96.2. This is our E2 and this is our E1. Now what you want to tell me? The turns ratio, nothing but N1 by N2. N1 by N2 is equals to E1 by E2 simply. Let's take E1 is a 6000, E2 415 into 100 divided by 96.2. These two zeros gets cancelled. So 5 12s are 5 12s are 5 8s are 5 3s are 12 by 83. This will come here. This will come here. So how much, sir? 12 into what is 12 into 96.2 divided by 83. What is the value, sir? Around this is 1 point change will goes. So 14 may be the answer. 14 may be the answer. Let's try to calculate, sir. Mostly 14 may be the answer. Let's try, sir. 12 into 96.2 divided by 83. 13.9. Approximately 14 will be your answer. Approximately 14 will be your answer. So what they given? Primary line voltage they given. Secondary line voltage they given. Of course, we can calculate from this also, but this is at particular load. Don't try to simply calculate this is a line voltage, so find the phase voltage. Don't try to like that, because this is a load voltage, not a EMF line. This is a load voltage. So that's why we need to calculate EMF. Then this is EMF. In the voltage regulation, what we can get are the phase voltages. Directly. So this is a phase voltage, and of course the 415 volts they given. Of course, we will take as a phase voltage. If it is line voltage, we need to change again. If it is line voltage, sir, if 415 volts is a line voltage, then what will be the answer, sir? If it is a line voltage, just calculate 415 by root 3, which is nothing but 240. Let's take 240. If this is 240, let's now try, sir. What is the value? Let's try, sir. What is the value? Voltage regulation is equals to 3.8% is equals to E2 minus 240 by E2. Now calculate the E2, sir. 3.8 into E2 is equals to 100 into E2 minus 240 into 100. Now what is the value? 240 into 100 is equals to, this will minus here. So 96.2 times of E2. Now what is E2 here? E2 is equals to 240 into 100 by 96.2. What is E1 by E2, which is turns ratio? 6000 by 240 into 100 divided by 96.2. 2 zeros, 3 zeros, 6 ones are 6 6 are. So the answer is 96.2 by 6. 6 ones are 6 ones are, and 36, 6 6 are. So here 16 is there. Is the answer 16 is there anything? There is no 16. So you need to check it. Actually, what they given? The terminal voltage 415 volts per phase. He has to given like that. Actually, 415 volts per phase they has to given, but they not mentioned. There is no any values. So simply I taken as a phase. If it is a line, if they given the secondary line voltage like that, if he mentioned, then you need to go like this. If it is a line, first we need to substitute here phase value. But in generally, what they given the terminal voltage is we need to consider as a phase voltage. Then we need to give the answer. The answer is 14. Next question. A single phase transformer fed from a rated supply voltage at no load. If we used air core, that is the point, sir. Actually, I think in the question it is missed. That is air core. If it is air core, in air core the BH curve is linear. If the BH curve is linear, if the flux is sinusoidal, our EMF also sinusoidal. To get a sinusoidal flux, the I mu also should be sinusoidal. The I mu also should be sinusoidal. Where air core, there is no nonlinearity. This is a linear BH curve. This is a linear BH curve. If it is a air core, if it is a iron core, this should be a peaky wave. This should be a peaky wave. Then this is sinusoidal, then this is sinusoidal. The magnetizing current should be a peaky wave. If it is a iron core transformer, it should be a peaky wave. But if it is air core transformer, it should be a D, sinusoidal magnetizing current. The magnetizing current will be, the current run by the transformer should be a sinusoidal if it is air core. Just simply, single phase transformer fed from rated supply at no load. If we used air core, the core loss of the transformer is assumed to be 0. They are telling that the core loss is 0, which is ideal transformer. In which the core losses are 0? In ideal transformer. For ideal transformer, BH curve is linear. For ideal transformer, BH curve is linear. Based on that, the current drawn by the transformer is where the iron losses or core losses 0, the IW 0. If the IW 0, I naught should be equal to I mu. What is my I mu? I mu will be sinusoidal. Then I naught also sinusoidal. Where the core losses are neglected, which is the ideal case. Okay, guys. Next. If a sinusoidal voltage source is connected to a power transformer, the no load current will be, you know already, the no load current will be, if this is a supply voltage, and here is our IW, and here is our I mu, and here is our I naught, here the angle is phi naught. The no load current is lags behind the supply voltage by nearly 90 degrees, but not equal to 90 degrees. It may be around 80 degrees, 75 degrees, etc. Sinusoidal, here the thing is that if the sinusoidal voltage is connected to power transformer, the no load current, generally power transformers are made up of iron core. This is non-sinusoidal. This will be a non-sinusoidal. If the supply voltage is sinusoidal, rich in third harmonic. What is that? Rich in third harmonic. So rich in third harmonic and fundamental would lag the voltage by 90 degrees. Rich in third harmonic and fundamental will be lags the voltage by less than 90 degrees. This is rich in third harmonic and lags the voltage nearly 90 degrees, not equal to 90 degrees. Next, if all other requirements of parallel operation of transformers are fulfilled, Which of the following pair of three-phase transformers with the given vector groups can be operated in parallel? Star delta star star, star delta star star, which is not suitable. Star delta and delta star. Let's think later. Delta 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 star, which is not suitable. Delta 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 star, which is not suitable. So among all these, which is preferable? This one is okay. But actually, if this is star delta, this will be delta star 1 is the best. Delta star 1 is the best. But here they given, of course, delta star 11. But there is no other best option than this. Star delta star star not suitable. Delta 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 star not suitable. Delta 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 star not suitable. So this is the best suitable answer for us. Yes or no, guys? Next. Match the following: power transformer, auto transformer, welding transformer, isolation transformer. First of all, isolation transformer, nothing but same number of turns, same voltages. Isolation transformer. Next one, welding transformer. The required voltage for welding is 10 volts to 15 volts or 20 volts in that range. So the output is very less voltage, very step down voltage. So among these, for welding transformer, this is most suitable because step down up to 100 volts we can. Next, Auto transformer and power transformer. Power transformers are generally high rating transformers, we can say. Of course, auto transformer also, but auto transformer K value should be near to 1. K value should be near to 1. Here, if you calculate K, LV by HV, which is very less, 1 by not even 11 something. Yes or no? The K value is very small value. This is not suitable as a auto transformer. We can use it as a power transformer. But here K is equals to 220 by 240, which is equals to 11 by 12, almost nearly equals to 1, which is best suitable. The K value should be nearly equals to 1. So 1, 4, A4, A4, B2, C3 and D1. D1. Option A will be your answer. Option A will be your answer. A delta star transformer has a phase-to-phase voltage transformation ratio of K. K is the delta phase voltage to the star phase voltage. Delta phase voltage to the star phase voltage. Delta phase voltage to the star phase voltage. Line to line voltage ratio of star to delta. Star line voltage to the delta line voltage. What is star line voltage? Is root 3 times of star phase voltage. Root 3 times of star phase voltage. Root 3 times of star phase voltage. What is delta line voltage? Delta line voltage is equals to delta phase voltage. Delta line voltage equal to delta phase voltage. So delta line voltage equal to delta phase voltage. Phase voltage of star to the phase voltage of delta. Reverse of this. So root 3 by K will be your answer. Root 3 by K will be your answer. They given delta phase to star phase K. But here I want star phase to delta phase in reverse. Like a question, sir, actually very important for Genco Transco, sir. We can expect like a questions. Next, which three-phase connection can be used as a transformer to introduce 30-degree phase displacement? In plus or minus 30 degree, we have delta star, star delta, and star zigzag star, In 0 or 180-degree phase group, we have delta delta, star star, and delta zigzag star. You know this. So this is 30 degrees plus or minus 30, 0 or 180, 0 or 180, delta zigzag also 0 or 180. Option A will be your answer.